So how do we solve radical equations? Key things to remember, just like any other equation, we've got to make sure the right-hand side is 0. And you should do this, especially in radical equations, if there is only one radical in the equation. If we have two radicals, then moving both radicals to one side actually will cause more problems. The second, we've got to check to see if the solutions are valid. We always check solutions when it comes to any equation by plugging things back in. But sometimes we may end up with an answer that's weird, and when you plug it in the equation, it may not satisfy the equation. So we should always try to check the validity of the solution. So here is an example. We want to solve for x. Suppose I have square root of 5x equals 3. Now, this is a case where you have only one radical, and you may say, well, I can move that 3 to the other side and solve. Sure, but that's just going to make things more complicated. I'd rather keep that 3 on the right-hand side and square on both sides. So we will have square root of 5x, the entire thing squared. And that would be equal to 3 squared. The root and the square will get cancelled. So 5x would be equal to 3 squared, which is 9. Divide by 5 on both sides. X is simply 9 over 5. And that is going to satisfy the equation. So I should probably put a note and say, in some cases here, because I don't want you to move 3 to the other side, to the left-hand side here, and try to solve the problem. Of course, it's doable, but why make things complicated unnecessarily? Here is an example for you to solve. So all we have to do is square on both sides. So square root of 4x squared would equal 7 squared. The root and the square will get cancelled. So 4x would equal 49, which would mean x is 49 divided by 4. Here is another example. So you may be tempted to just square on both sides and find a solution. Well, that's okay. It's not advisable because, once again, you're going to make the problem complicated. So I'm going to keep square root of x minus 1 in one side and move the number to the other side. So I have a single expression equal to a single number. Now I can square on both sides. So square root of x minus 1 squared would be equal to 1 squared. The root and the square will get cancelled. X minus 1 would equal 1. Move the negative 1 to the other side, it becomes positive. So x is equal to 2. So I'm going to move a number to the other side. So square root of 2x minus 3 equals 1 plus 2. 1 plus 2 is 3. Now I'm going to square on both sides. So square root of 2x minus 3 squared would equal 3 squared. The root and the square will get cancelled. 2x minus 3 would equal 9, which would mean 2x equals 9 plus 3. 2x would equal to 12. Divide by 2 on both sides. X will be equal to 6. So I'm going to move the number to the other side. So I'll get 8 plus 4, which is 12. Now I have a radical on one side, number on the other. I am going to square on both sides. The root and the square will get cancelled. So 3x plus 3 would equal to 12. That would mean 3x is equal to 12 minus 3. Sorry, 12 squared, bad algebra. So 12 squared is 144. So 144 minus 3, which would mean 3x is equal to 141. Divide by 3 on both sides, we will have 141 divided by 3, which is 47. What if we had a cube root instead of a square root? It does not change the process at all in terms of moving things around and whatnot. What we do is, instead of taking the square root, we take, instead of squaring on both sides, we cube on both sides. So here is an example. I have the third root. So I'm going to move the number to one side. So I have a cube root on the left-hand side, 3 on the other side. I'm going to raise both sides to the power of 3. The root and the cube will get cancelled. X minus 2 would be equal to 3 cubed. 3 cubed is nothing but 27. So x is 27 plus 2, which is 29. Here is another example. So I'm going to move the number to the other side. So 4, going to raise both sides to the power of 3, or raise the terms power of 3. So we're cubing on both sides. The root and the cube will get cancelled. So 2x minus 6 would be equal to 4 cubed. 4 cubed is 64. So 2x would equal to 64 plus 6. And move the negative 6 to the right-hand side. 2x would equal to 70. Divide by 2 on both sides. We'll have 70 over 2. So x is 35. Here is a slightly different type of problem. Requires a little bit of work, but doable. So I have x on the left-hand side, x on the right-hand side also. So I'm going to square on both sides like I always do. So square root of 13 minus x squared would be equal to x minus 1 squared. The root and the square will get cancelled. So we would have 13 minus x equals, I have x minus 1 squared. To solve this, I have to FOIL. If I FOIL x minus 1 squared, which simply is x minus 1 times x minus 1, I'd end up getting x squared minus 2x plus 1. I'm going to move all terms to one side, so the right-hand side, or one of the sides is 0. So 0 would be equal to x squared minus 2x plus 1 plus x minus 13. X squared minus x minus 12. So the equation that I have to solve is x squared minus x minus 12. The only way to solve this as of today, based on what you know thus far, is factoring. In the next chapter, we'll go over the quadratic formula, which can give you the answer right away. Could we factor this expression on the left-hand side? Absolutely. I can factor it as x minus 4 times x minus 3. Excuse me, x plus 3. So I have two factors. I want to set each factor equal to 0 and solve for x. So x is equal to 4 and x is equal to -3. So the two solutions are x equals 4 and x equals -3. So I'm going to square on both sides. The root and the square will get cancelled. So we would have 2x minus 3 equals 3 minus x whole squared. That is simply 3 minus x times 3 minus x. If I FOIL, I'll end up getting 9 plus x squared minus 6x. Going to move all terms to one side so that the other side is 0. 9 plus x squared minus 6x minus 2x plus 3. Which would mean x squared minus 2x minus 6x plus 12 is equal to 0. And I'm not going to combine the middle two terms because just by looking at it, I know that we have the factors that we need. The factors in this case are simply x minus 6 and x minus 2. And if I set each of them equal to 0, I'll have x minus 6 equal to 0, which would mean x is equal to 6. X minus 2 equals 0, and that would mean x is equal to 2. So the two solutions are x equals 6 and x equals 2.